You've been hired by a tennis ball company to help them optimize their packaging for their balls. They're considering two options, a rectangular box or a cylindrical tube. But which one leaves more empty space? That's where you come in. Here's what you know. 1. The balls are packed tightly in both containers. 2. All the balls are the same size. 3. Each ball has a volume of 150 cubic centimeters. Let's take a look at this rectangular box. If we view it from above, we'll see 6 tennis balls arranged snugly inside, forming a rectangle. That's straightforward, but how do we determine the width and length? Let's focus on a single tennis ball, represented here by a circle. The diameter of a circle is the total distance across it, passing through the center. Now, if we place these circles inside the box, we can see that the length of the rectangle is made up of 3 diameters, which we write as 3D, and the width is made up of 2 diameters, written as 2D. This means we can rewrite our area formula as area equals 2D times 3D. That's great, but how do we determine D? Remember, we were given that the volume of each sphere is 150 cubic centimeters. The formula for the volume of a sphere is V equals 4/3 times pi times r cubed. Since we know the volume, we can substitute 150 into the equation and solve for r. First, divide both sides by 4/3 times pi to isolate r cubed. Then, take the cube root to find r. Plugging this into a calculator, we get r approximately 3.296 centimeters. But remember, r is the radius and we need the diameter. Since the diameter is twice the radius, we multiply by 2, giving us 6.592 centimeters. Now, let's go back to our area equation and substitute in the diameter we just calculated. Don't forget the units. You're doing great! We've found the area of the rectangle, but now we need to move back into 3D space. To do this, we multiply the area by the depth, represented as z. Luckily for us, since the sphere is equal in all directions, its diameter also defines the depth. Now we can calculate the total volume of the rectangular box. With the box's volume determined, we can place the tennis balls back inside. Since each ball takes up 150 cubic centimeters, we simply subtract the total volume occupied by the balls from the volume of the box to find the empty space left over. Plugging in the numbers, we get 47.64%. So the empty space makes up 47.64% of the total volume.